Okay, here's what you can expect on your final. I think your final is, if you're in first hour, it's on January 13th, second hour, January 14th, or 6th hour, January 14th. Okay, this is inequalities. You haven't taken this one before. It'll be given once on the day of the final. So write an inequality for each graph. That basically means just label the graph. Okay. You're going to put x, -7, and that way you're going less than, so you use the less than symbol. Pretty easy. x2, use x for your variable. This time you're going greater than, okay? So greater than, you use that symbol. You also put a line under the symbol because you can be equal. Okay, you get two separate ones. They spread apart, so I put x2. We're going greater than, use a greater than symbol. Don't put the line under. And then x, -6, that way you're going less than. So you put the less than symbol. It's filled in, so you're going to put the line. Okay. Usually I write or between the two, but I'm not going to dock you if you don't. Now, when I have a line, just one line, and it's between two numbers, I put x down just once. We put -3 and 2. Here we have to eat the 2 because that's the maximum. Here we do not eat the -3. Okay, we need to eat the x. Okay, and we don't put lines underneath because neither one of them are colored in. Okay, first problems are easy if you know what you're doing. Now you're going to be solving inequalities for x, okay? X plus 3 less than or equal to 16. So I make my number line first. I only see one symbol, okay? So first off, x would have a 1 multiplier. It's +1, so that sign stays the same. Okay, now first we have to do the -3. Now when I'm minusing and adding, I don't go here. Okay, I do a step in between. That's going to give you 13, and that's going to give you 1x. Okay, you can divide by 1 or just take the 1 off. So you have x, 13. Now you got to put it on the graph correctly. Circle the lines there so we fill it in. It is not eating the x, so it goes this way. And please label that x, 13. You're going the less than direction, so we use the less than symbol, then equals. Okay, number 6. Okay, x has a -2 as its multiplier, so that sign is going to change because we'll be dividing both sides by a negative. Do I first check and see if you have to add or subtract? You don't. So now you just go divide, straight to division by -2. So we have x over here. 8 divided by -2 is -4. Okay, so we have -4, circle, fill it. And it is not eating the x, so it goes this way. So I put x, -4, going this way is less than. Okay, so less than, put the line under if it's colored in. Okay, don't get freaked out by the fraction. It works the same way as with the integers. Okay, x has a multiplier of -1/4, so it's a negative multiplier, so that symbol has to turn the other way. Now we don't add, we don't subtract, we go straight into the dividing by the fraction -1/4. So we have x. On a calculator, 8 divided by -1/4. Now I'm going to tell you, when you're dividing by -1/4, you're actually multiplying by -4. Which is why when I punch this in, you're going to get -32. Okay, so -32, circle, fill it, not eating the x, so it goes this way. Right now we're on a big streak of not eating the x. So x, -32, going that way means I need to put the less than symbol between. It has to eat the -32, not the x. Okay, number 8. 2x less than or equal to 4x plus 10. Okay, so we have x's. We have two of them. They're on opposite sides, so we're going to get this one here to 0, because if I'd get rid of that one, there's nothing there, and that confuses people. So we'll minus 4x minus 4x. Okay, line that up. See, I don't know what way the sign's going to go because I have to simplify the inequality so that the x appears just one time. So I have negative 2x, and we have 10. So right now I see my x has a multiplier of negative 2, so that sign needs to change. Forgetting to change signs on negative multipliers will result in a poor grade on this. Divide by negative 2, and we end up with x, and then negative 5. So now it does eat the x, fill it in, so it's going to go this way. That is the greater than direction, so I put x, negative 5, greater than or equal to symbol. Okay, number 9, make your number line. We got a lot of simplifying to do before we worry about what's going to happen to that symbol. So first, okay, we're going to use the distributive property, so it goes 6. 6 times 1x is 6x. 6 times negative 1 is negative 6, so minus 6. Then I have my symbol. Then I have negative 18 plus 6x. Still don't know what's going to happen with my symbol because we have two different x's in the problem. Okay, since they are identical, we're going to cross them out, and that allows me then to forget about my number line. This is no solution or any solution. Now, with a symbol, with a less than symbol, find the higher number. Negative 6 is the higher value. Okay, the sign should open up, it should eat that, but it does not eat the higher number, so that is no solution. If it's eating the higher number, it's any solution. Okay, number 10. Ooh, if you see two of the symbols, you better make a table, okay? Because you're going to split it into two separate problems. You're going to make your number line, but with two symbols like that, we're going to make that table. And I'm going to do the overlap here. So negative 1 less than or equal to x minus 3. Then in the other column, I take my x minus 3, use the symbol given there, and then 2. Now I solve each one separately. So I've got 1, that's a positive multiplier, so we will be keeping that symbol pointed the same direction. Plus 3, line up your symbol, and you have 2 and 1x. Okay. You may divide by 1 or cross out the 1, so I have 2 and x. Okay, 1. So the symbol will not change because that's a positive 1. And then I plus 3, 2 plus 3 is 5. So we have 1x less than or equal to 5. You can divide by 1 or just eliminate the x. Okay. Now you got 2 and 5. I plot those two numbers, both positives, and I'm going to color in both circles. Now is when you got to really focus. This is eating the x, so it goes this way. Now some people get really confused. They're like, well, that's a less than sign. Well, that's true, but if you turn it around so the x comes before the 2, then the sign flips and it is greater than. That's why if you use the eating rule, we don't have to worry about that. Okay, eats the x, and x is bigger. Okay. Here it does not eat the x, so that goes in, and we end up with one single line. So we put x, 2, and 5. We eat the 5, and here we eat the x. Okay, that's compound. Next one, I see two symbols, but they're already separated for us. We don't have to do the overlap. I go to my table. On one side, I put 8 plus 2x greater than or equal to 4, and on the other side, negative 3x greater than 30. Pay attention to those multipliers, please. This has x multiplier of 2, this x multiplier of negative 3. This one, the symbol stays the same because it's positive 2. This one is negative, so the symbol flips. So we got this 8 here we got to deal with, minus 8 minus 8. So line your sign up. Remember, don't come down here until after you divide. So it's negative 4 and then 2x. Now it's dividing time by 2. X, negative 2. So negative 2 is our critical number there. Actually, let me get the other one first. Here we go straight to the division. So x sign turns because we're dividing by a negative, and that's negative 10. Okay, so negative 2 and negative 10, I'm going to extend that line further because negative 10 would be out here. Circle over both of them. That's filled in, the one with the negative 2, and it eats the x, so this way. Here it's not, the line's not there, so I leave it empty, and this time it does not eat the x, so it goes out this way. Okay, so we have them going the opposite way. Okay. All right, so then when they're separate like that, okay, x, negative 2, that's going greater than, so put the greater than symbol. This is going less than, okay, that way, so x, negative 10, put the less than symbol. You can put the word or between, I'm not going to require that, okay. Okay, now we have an absolute value inequality. Okay, with absolute values we make our table. Go inside and you have x minus 6. You're going to write that down twice. Make sure you don't have an a or a k, which you don't. You're going to make the graph. Okay. So the 1 can be labeled from 0. Now remember, you put the symbol with 1 on this side and you flip the symbol and do negative 1 on the other side. Okay, so 1, 1. So it's positive 1, so the symbol stays the same. And then plus 6, 1x greater than or equal to 7. You can get rid of the 1 or divide by it, so x 7. Now here, the sign's going to stay the same. Plus 6, that's 5. Then you can get rid of the 1 if you want. So you got x and 5. So you got two positives, 5 and 7. Okay, you'll fill in both circles because they're both. Now let's talk about the 7. It eats the x with the 7. Okay, so it goes this way. Here it does not eat the x, so it needs to go to the left. Again, follow this right here and you're good to go. Okay, those are separate, so x, 5, 7, okay, goes less than that way with the bar, greater than that way with the bar, okay. Okay, and that's how you do an absolute value with inequalities. You're going to make the table, okay, do 1 and negative 1. Now the next page we have absolute values, but they're just equations, okay. We don't need to use our little table, our graph. We're going to use the table for sure. 5x plus 2, 5x plus 2. There's no a, there's no k. Okay, so you're 12 from 0. So on one side you just put equals 12, and on the other side you put equals negative 12. And you don't have to do a number line because it's just equals. It's not greater than or less than. So minus 2, that's 10. Divide by 5, that's 2. Okay. It's just equal to 2, so we don't need the number line. So 5x equals negative 14. And negative 14 divided by 5, negative 2.8. Okay, and those do not need to be graphed because they're just equals. Okay, now this time you got x plus 2 in the absolute value. But you don't know how far you are from 0 because you have a k here and an a here. First we get rid of the k. That's 9. So line your equals up and you have 3, absolute value x plus 2. And then a, so then you divide by 3. And now that's at 3. Remember, a values you divide by. So now you're 3 from 0. Okay, so you go 3, negative 3. You can put the 1 if you want. You just need to minus 2. You don't have to worry about a sign flipping because it's just an equals. You can drop the 1 or you can divide. 1's the answer. Okay, negative 5. You can drop the 1 or you can divide. You're still going to be at negative 5. You don't need to do a number line because it's just equals. Okay, story problems. These are not hard to set up, okay? Now, so on this paper, can you put greater than is with goals? I use that in a story problem. Less than is have, okay? Okay, your goal in history is to get a 90 average for your test. So far, you've got 95, 86, and 93 for your test. Write and solve an inequality. That is big capital letters. It means we're going to use these symbols. Possible scores you can get on your next test and meet your goal. So goal is the greater than. Put an equals to. Now your goal is 90. Put 90, cross it off. Now look up top and I wrote a little hint. Average rule. That's a division. Now on top of the line you write down the test you've already got with plus signs. 95 plus 86 plus 93. I'm going to take another test, so that's X. So that's 4 tests, 1, 2, 3, and then the unknown's 4. So down here I'm going to put a division line, I'm going to put 4, and I'm going to put X, but then what I'm going to add to X is I'm going to add the 3 tests that I know. 95 plus 86 plus 93, 274. Now, get rid of this 4. When the whole side is divided by 4, scribble out the 4, and we're allowed to do that as long as we times 4 to the other side. So now that's 360, and on the other side I'm at X plus 274. You just minus 274, and you essentially have your solution. You don't have to graph on a story problem. 360 minus 274 is 86. So you have to score an 86 or better on that next test to meet your goal of 90. Anything less than an 86, you're going to fall below your goal. Anything greater, you'll meet it. Okay, number 16. You have 200 feet of fence to put around a rectangular garden. The width of the garden is 40 feet. Write and solve an inequality of possible lengths of the garden. Now it says have, so we're going to use less than for our symbol. We have 200 feet. Okay. Cross out the 200. Now, go on this rectangle. You have 4 sides. There's 2 of each, 2 widths and 2 lengths. Put 2 times W, 2 times L. But I can get rid of one of these letters because it tells me that the width of the garden's 40 feet. So the W is 40. So this is 80, and this is just still 2L. So on this side I put 2L plus 80. Okay, then you're good to solve it. You don't have to worry about the sign flipping. You have a positive multiplier. So that's 120. And then I'm going to divide by 2. And that ends up as 60. So L is less than or equal to 60. Okay. Okay, number 17. You're cutting sheets from metal. Each sheet should be 34.25 feet long and 30.85 feet wide. The lengths and widths must be within 0.1 of the desired size. Write inequalities that represent the range of both the length and width. Okay, range. Let's take our length, what it's supposed to be, and then I add and subtract what it must be within, 0.1. Okay. So I put L. 34.25 plus 0.1 is 34.35. That goes here. And if I minus 0.1, it goes down to 34.15. Okay, here it eats the maximum. It never eats the minimum. It would have to eat the L. Okay, and that's your answer. Width. The width is supposed to be 30.85, but again, it can be within 0.1. So I put W, and on one side I add 0.1. That's going to be 30.95. Use a calculator if you're not good with decimals. Now on the other side, we're going to minus it, and that's 30.75, because it's like 0.10, so same thing, okay? All right, that's what you expect. No, so for story problems, you got your range. It's when you add and subtract. Please remember how to write your inequality. Remember, I got that to show you. There's 4 sides, but 2 of them times L, 2 of them times W. One of them you know, and you write it out, solve the other one. And then there's the average rule, okay?